The topic of our today's video is enlargement. It is a part of transformation. So, as we know that the learning objectives are all together of reflection, rotation, translation, and enlargement. I have already uploaded a video of reflection and translation. Now today we are working on enlargement. In enlargement, we need two things. One is the scale factor, and the second thing is the point of enlargement. If they are asking to enlarge the given object, then they will give you these two things. The first one is point of enlargement, and the second one is scale factor. Scale factor means that how much we will enlarge our figure, and the point of enlargement is from which point we will consider the enlargement. So if we read the first question, here we have enlarged triangle A with the scale factor 2, and the point of enlargement is origin. So origin is 0, 0. First we will mark the origin. So here we have marked this origin 0, 0. Then to enlarge a given object, one by one we will join each vertex with the point of enlargement and extend the line. Where we will extend the line, it will depend on the scale factor. If the scale factor is positive, so we will extend the line towards the given object. And if the scale factor is negative, then we will extend the line on the opposite side of the point of enlargement. If the scale factor is positive, then we will have an object and image on the same side of point of enlargement. And if the scale factor is negative, then we will have object and image on the opposite sides of point of enlargement. Now here if we read the first question, enlarge triangle A with a scale factor positive 2 and the point of enlargement is origin. So as we have already marked this origin, what we will do, we will join each vertex of this triangle with the point of enlargement and extend the line on the same side. So if we join this vertex with the point of enlargement, we will extend the line on the same side. Okay. Now after this, what we will do, we will check the distance of object and the point of enlargement. As here we have one box, so 1 multiplied by the scale factor. Now this is 2. So remember, whenever we mark the image, we will always count the distance from the point of enlargement. Either the scale factor is positive or negative. So if we count the distance from the point of enlargement, here we have one box and here we have two boxes. So this is the image. Then if we join the second vertex with the point of enlargement, we will extend the line on the same side. Okay, here we have the object and we have extended this line. Now if we check what is the distance of this object from the point of enlargement, so this is 1, 2 and 3 boxes. Okay, 3 multiplied by 2 will be 6. Now we will mark 6 boxes and we will count the distance from point of enlargement. So here we have 1, 2, 3, 4, 5 and here we have 6. So this is the image. Now we will join the third vertex with the point of enlargement and extend the line on the same side. Now we will check the distance of this object from the point of enlargement. So as we have 1 and 2 boxes, so 2 multiplied by 2 is 4. So now we will mark 4 boxes and we will count the distance from point of enlargement. So start from point of enlargement, 1, 2, 3 and 4. So this is the image. Now when we join these 3 image points, here we have an enlarged figure. So we have enlarged this given object with a scale factor positive 2 and the point of enlargement was origin. Now if we move towards the second part, here they are saying that the point of enlargement is uh, 0 and 1, and the scale factor is -3. So first we will mark this scale factor. So if you mark this scale factor, it is 0, 1. So here we have this scale factor 0, 1. Now when we join each vertex with this, we will extend the line on the opposite side of point of enlargement. Why? Because the scale factor is negative. So if we join this vertex, as these two vertex are lying, these two vertex are lying on the same line. So if we join this with the point of enlargement, we will extend the line on the opposite side. Now, if we take this first vertex has one box distance from the point of enlargement. So 1 multiplied by 3 is equal to 3. Okay. So we will mark 3 boxes on the opposite side of point of enlargement. So 1, 2 and 3. Its image is here. Okay. Then if we check this second box distance, here we have 2 boxes. So 2 multiplied by 3 is equal to 6. So here we have to mark 6 boxes, and we will count the distance from the point of enlargement. So here we have 1, 2, 3, 4, 5, 6. This point is here. Okay. Now we will join the third vertex with the point of enlargement and extend the line. So if we join this with the point of enlargement, this is our extended line. Now we will check the distance. So this distance is 1 and 2 boxes. So 2 multiplied by 3 is equal to 6. Now we will mark 6 boxes, and we will start the distance from the point of enlargement. So 1, 2, 3, 4, 5 and 6. Here we have image. Now when we join these 3 vertices, this is our enlarged figure. And the scale factor is -3. So if the scale factor is positive, then we will have an object and image on the same side of point of enlargement. And when the scale factor is negative, then we will have object and image on the opposite sides of point of enlargement. So I hope this is clear, the positive factor and the negative factor. Now, for example, object and image both are given in the question. And here they are saying describe the single transformation maps triangle A onto triangle B. So here we have object and image. A is object and B is image. Triangle A onto triangle B. So this is object and this is image. Now object is greater than the image. Now here what we will do, when we to find the we know that in enlargement we cannot only write that it's enlargement, we need to mention what is the point of enlargement and what is the scale factor. So first of all, to find the point of enlargement, we will join 2 same vertices of object and image. Like if this vertex is here, we will join these 2 vertices. So when we join these 2 vertices, here we have joined these 2 vertices. Now we will join one more same vertices. Okay, and for this, if we join this one is here. You can join the third one also, it's up to you, but you will join any 2 same vertices. Okay, so if I join these 2 vertices, blue one, where are these 2 lines are intersecting, that is the point of enlargement. So this green line and blue line are intersecting at this point. So this is our point of enlargement and this is 5, 5. So we have got the point of enlargement. We know that it's enlargement. What is left? Scale factor is left. So for scale factor, we have a particular formula that the distance of image from the point of enlargement divided by the distance of object from the point of enlargement. If we follow that formula, we will get the scale factor. One more thing, like if we take just one side of an object and the same side of image, through that also we can find the scale factor. Like from the object, if we are taking this side A, okay, here we have two boxes, and if we take the image of this, here we have just one box. Okay, so in numerator we will write the image, and in denominator we will write the object. So scale factor is equal to image and divided by object. So image has 0.1 and object has 0.2. So here the scale factor is 1/2. One more thing, remember that whenever we have a scale factor in fraction, the image will be smaller than the object. Here you can see that A is bigger and the image is smaller. So it's not necessary that image will always bigger than the object. Sometimes the image will be smaller than the object. So in that case, remember that the scale factor will be in fraction, either 1/2, 1/3, 1/4, like these. Okay. So as we have discussed in the last question, that when the object and image are on opposite sides of point of enlargement, then the scale factor will have a negative sign. So here, as we can see that the point of enlargement is in the center, and one side we have object and on the other side we have the image. So here we will write the negative signs of the scale factor. So here the scale factor is -1/2. When we write the answer, we will write its enlargement with the scale factor -1/2 and center or point of enlargement 5. This is how we will write the answer. If you don't describe it completely, then the examiner will not give you marks. Okay, as I have told you that when we have a translation, that it's necessary to write the translation vector. If we have reflection, that it is necessary to write the line of reflection equation. And in enlargement, we can if we just write its enlargement, then that is incomplete answer. You should mention that what is the point of enlargement and what is the scale factor. If you write these two things along with the enlargement, then the examiner will give you full marks on that. Now last, here we have one more example. Describe the single transformation maps triangle X onto triangle Z. So X onto Z, we can see that here we have an enlargement. So first of all, to find the point of enlargement, we will join the same vertices, two same vertices. So when we join two same vertices, first of all, if we join these two, okay, and then if we join these two, okay, so here we can see that our point of enlargement is 5, 1. Okay, we have joined two same vertices and extend the line. Here we can say that here we have an point of enlargement, that here we have an object and this is image. So it means that on the object and image are on the same side. Okay, so the scale factor will be positive. Now to find the scale factor, as I have told you in the last question, that here X is object and Z is image. So the formula of a scale factor is image divided by object. So if we take same one side of the object and the image, so here if we take this side from the image, here we have 1, 2, 3, 4 boxes. 4 divided by, if we take the same side of the object, here we have 2 boxes. So we will divide this by 2. So the scale factor is 2, and it is positive 2 because the object and image are on the same side of point of enlargement. So when we write the answer, we will write its enlargement with the scale factor positive 2 and center 5, 1. This is how we will write the complete answer. Okay, so we have discussed that when the point and the scale factor is given, then how we will draw the image. Okay, and if it is positive, then on the same side. If it is negative, then on the opposite side. Then when the object and image both are given, then how we will find the point of enlargement and the scale factor. Here we have discussed one of the example in which we were getting the negative scale factor, and the image was smaller than the object. And then we have discussed one more case where we had a positive scale factor and the image was bigger than the object. So I have discussed both examples with you. Okay, I hope you have understood this. One more thing they can ask in the question, that is matrix of enlargement. So remember, the matrix of enlargement is K00K. Here K is the scale factor. Okay, like in this question, when we get the scale factor negative half, so if we write its matrix, we know that the matrix is K00K. So K is the scale factor. So the matrix of this enlargement will be negative half, 0, 0, negative half. This is the matrix of this enlargement. Similarly, if we write the matrix of this enlargement, we know that the matrix is K00K. Here the scale factor is 2. So the matrix will be 2002. Okay, this is called the matrix of enlargement. The matrix of enlargement is very easy to remember, that K00K, and we will write scale factor only in the matrix of enlargement. One more thing, that if they ask that find the area of the image, so we will take the square of the scale factor and multiply it with the area of the object. So we will get the area of the image. And as I have told you that the formula of scale factor is distance of image from the point of enlargement divided by the distance of object from the point of enlargement. Here you can use this formula also to find the scale factor, but it is easy to just use this scale to find the scale factor. Take one side of object and the same side of image, and then write image in the numerator and the object in the denominator. So you will easily get the scale factor. Okay, so it's better to use this formula. Otherwise, if the formula which I have written, if you use that formula, so I have written the distance of image from the point of enlargement. So if we take this point of object and image, like here we have this point, if we take its object and this is the point of enlargement. So see, the distance of image from the point of enlargement is 1, 2, 3 and 4 boxes. So in numerator we will write 4, and the object has 1 and 2 boxes distance, so this is 2. So in the same way we will get the scale factor positive 2. Okay, but see that it is easy, like if you take just one side of object and image and write the image in the numerator and object in the denominator, so you will easily get the scale factor. Okay, so it's easy to use scale image divided by object. Okay, and remember this matrix, the matrix of enlargement is very easy, that is K00K. Okay, I hope this enlargement is clear to you. Thank you.